And welcome back to another lesson in pre-calculus. Today, we'll be taking a look at the second part of section 4.2, where we'll be looking at the composition of trigonometric functions and their inverses. Before we do this, we have to recall how to determine if two functions are inverses of one another. Remember, if I have a function, and we'll call the function f of x, and I have its inverse, which we'll call f inverse of x, which is that little -1 means inverse. If I take the inverse function and put it inside of the original function, so that would be f of f inverse of x. If I did this, then I will get x after I simplify this composition of functions. This is true as long as x is in the domain of f inverse. Okay. For example, if I have the function, y equals x plus 2. Okay. Well, what is its inverse? Its inverse would be I switch x and y. So x equals y plus 2. And then I solve for y. So it means x minus 2 equals y. And we'll put a little inverse sign just to show that it's the y inverse. So if I take this function and put it inside of that one, I should get just x. Let's try it out. So we'll call this f of x, and we'll call this f inverse of x. So f of f inverse of x would be taking x minus 2 and putting it into x. So it would be x minus 2 plus 2. And when you do that, the minus 2 and plus 2 cancel out, and I get just x, and I can see that those two functions are inverses of one another. So if they are inverses, this will be true. So how can we apply that to trigonometric rules? Well, if I take my inverse trig function and stick it inside of my regular trig function, I should simplify down to just x, assuming that x is in the domain of my inverse trig function. Now, so this is true as long as x is in the domain of sine inverse. Remember, the domain of sine inverse is negative 1 to 1. So assuming that x is between -1 and 1, then this will be true. This is not true if x falls out of this domain. Same thing for cosine. If I take the inverse function and stick it inside of the cosine function, I should simplify down to x, assuming that x is in between -1 and 1, because that is the domain of cosine inverse.